So for A, we've got cos squared pi over 4 minus sine squared pi over 4. Those are values on your pi plate. In this case, I would probably just, since they're on your pi plate, the first thing you're going to think of is I know that cos of pi over 4 is root 2 over 2, so cos squared will be root 2 over 2 squared. Minus sine of pi over 4 is root 2 over 2, so sine of pi over 4 squared would be root 2 over 2 squared. Can you see that they're the same? This is going to be 2 over 4 minus 2 over 4. You're going to get 0. That would be the most likely thing you'll see, and if you did that on an exam, full marks. That's why generally they don't use pi over 4. They'll use pi over 12 or pi over 8. Because what they were hoping in the textbook is that you would recognize this as cos squared minus sine squared. And if it's cos squared minus sine squared, that's equal to cos 2 times pi over 4. And cos 2 times pi over 4 is just cos of pi over 2. And on our pi plate, cos of pi over 2 is 0. So in my opinion, this is not the greatest question, because if they really wanted to test that you knew it was a double angle, then they should use an angle that you can't do directly. Same thing with this one, pi over 6. You could just do it directly. It's a little bit nasty with all of the fractions that would be involved. Can you see that this matches up almost with the tan 2 alpha formula? Almost. Because the tan 2 alpha formula looks like this. It's got 2 tan alpha, which matches up perfectly with what we have, but it has 1 minus tan alpha on the bottom instead of, or 1 minus tan squared alpha on the bottom instead of tan squared minus 1. How do I change this to a 1 minus? Take a negative out. So if I rewrite 2 tan pi over 6, take a negative out of the bottom, then I would have 1 minus tan squared pi over 6. Wow, that's ugly. Here we go. Tan squared pi over 6. Now something about fractions and negatives. Is everybody okay that if I have negative 1/2, that's the same as 1 over negative 2, which is the same as negative 1/2? You can have the fraction with the numerator, the denominator, or just out in front. Yes?
What's the difference between the first tan formula and the second one?
Well, this, I'm going from here, okay, down to here. That's where my pi over 6's are. I'm factoring a negative out of the bottom so that it matches up with the formula that we have where it's 1 minus instead of tan minus 1. So this becomes negative tan 2 alpha. And that just becomes pi over 3. And tan of pi over 3 is root 3, so we get negative root 3. In this case, using the double angle formula is nicer than plugging in our values, because you can imagine if we plugged in our values, we'd have root 3 over 3 here. We'd have this whole thing, root 3 over 3 squared there, and fractions inside of fractions, which isn't too bad, but not as elegant as this. 4, 5, and 6 are ones you can do after example 2.